Alright, so we got a multi-part coffee problem here. So we've got a company that specializes in brewing coffee, and then we've got a bunch of problems here we want to solve. First off, we want to find out the demand slope based off of the price. So to do that, what I'm going to do here is I'm going to take, they mentioned here at a price of $4, we get 980 cups a day, and at 450, demand decreases a little bit to 915 cups. So to do that, we're going to have a slope, which is going to be m. I need to change my pen size. All right, hopefully you can read this. All right, so m is going to be equal to y2 minus y1 over x2 minus x1 for the demand. So what's going to happen here is we can pick any one, doesn't matter which one. So we'll just start off with 915 cups. So this will be 0.2. And then the second point will be 980 cups. And then that's all going to be all over. This is at 450 minus, and then at 980, that was at $4 a cup. So what we end up here with is negative 65 over 0.5, and that essentially ends up being equal to negative 130. So for every 50 cents you increase the cost of the cup, assuming it's a linear function, we're going to get 130 less cups sold a day. So if you increase it $1, it would go from, if you went from 450 to 550, 130, so I go 815, 785. All right, so the slope of the demand function, m equals negative 130. All right, so next part, find the vertical intercept of the demand function. All right, so what we do for this is we're going to take m. Well, we're going to do the point slope form, so it's going to be y minus y1 equals m times x minus x1. All right, so what's going to happen here is we're going to plug in, well, y is just the generic y, and y1's a point. So we pick any point, and since we have the slope now, we're going to do y minus y1. We'll just pick 980. And then it equals negative 130 times x minus, and then we're going to pick, so we pick 980, we'll pick $4. Okay. All right, so we solve for this. We distribute across, we get y minus 980 equals negative 130x, and then this ends up being plus negative 130 times 4, which is going to be 520. And then we add 980, and then what we end up with is y is equal to negative 130x plus 1500, which means if we plug in 0, so the y-intercept in this case, the vertical intercept, is going to be equal to 15. So it's going to be, if we charge nothing for the coffee, we'll sell 1,500 of them. Probably be a lot more than that, though. And we'll go bankrupt. Okay, so anyway, 0, 1,500 is the result there. So find the cost of producing 1,000 cups of coffee. So this is how many we sell there. So just the raw cost, if we look here, it costs the shop 60 cents to produce each cup of coffee. An associated daily fixed cost of 1,400. Okay, so for C, it's going to be our cost function. It's going to be straight up 1,400 plus, and then our x value, or 60 cents, and we want 1,000 cups, so we'll plug in 1,000 here. So it's going to be 1,400 plus 600, which is equal to $2,000. It's a lot of high fixed cost. All right, so that's going to be $2,000. All right, so we want to find the break-even point. So that means our cost is going to equal to the amount we bring in. So what we'll do here is we sell each cup for $4 $4.50. Alright, so we want to find the break-even function now. I'm going to take a guess here at how to do it. So basically we're going to set the cost function equal to the... Hold on. Alright, well, we're going to substitute in our y value here. So break even, I'll just put a sub even here, of x is going to be equal to 1400 plus 0.6, 60 cents, and then we're going to plug in our negative 130x plus 1500. So the price we need to, the number we need to sell at what price in order to, or number we need to sell in order to break even. Actually, I take that back. I'm sorry. What we need to do is we need to figure out how many we need to sell at 60 cents. All right, so we want the break-even price. All right, I finally figured it out. All right, so to do that, what we need to do here is we have our original equation. So break-even. So what we're actually going to do is we have our variable amount of how many cups we sell, which is going to be negative 130x plus 1500. And then what happens here is we multiply that times how much per cup, because the result's going to give us how much per cup. Because, sorry, this is a little deceiving. This is how many cups, even though that's how much per cup. That depends on how many we sell. And then this is how much per cup here. And then we're subtracting how much it costs to make a cup, which is 60 cents. And then we're going to set this equal to 1400. And this is basically a quadratic equation. But when we solve this, we end up with x is equal to $1.69, 393, but we'll round up to $1.70. And then x is also going to be equal to 10.4445, but we'll just make this 1044. No, 1044. We'll round these. Okay, so these are our break-even points. So if you plug this in, you'll get just the right amount of coffee to sell in order to break even. So here's our graph right here. I just wanted to add this in. And there's our break-even points. And next, what we want to do is find the maximization. So it'll probably be around here. So it looks like it's going to be like $6 or something. I have no idea. So what we do here is, what we do is multiply these together, or however you want to do that, and then we could just find the vertex. So negative b over 2a. And what that looks like, if we plug that in and get the maximum, what we end up here with is it looks like price that yields maximum profit is going to be $6.07 approximately. Yeah, it looks about right there. Okay, so we want to find the maximum profit. So all we're going to do is you plug that back into the equation we had. Negative 130 times 607 minus or plus 1500. X minus 0.60 minus 1400 equals some value in O. It should be 607. So that's the net profit from each cup of coffee. All right, and what we end up with is approximately $2,488.62 per day for a maximum. If we sell cups of coffee at $6.07, And finally, the last question we're going to have is what's the quantity needed? So all we do is we take our original question of how many cups, we'll just do f of c, is equal to, and we plug in our maximum profit value, which is going to be negative 130 times 607 plus 1500. It's going to be equal to however many cups, which ends up being 710.9, but we always round to the nearest cup. So in this case, it looks like we're going to be dealing with 711 cups. That's it. All right. I hope this helped you out. Thanks for watching. Have a great day.